Hello and welcome to this brief video. My name's Ryan Kane and I want to talk to you a little bit about my intended proposal. And the proposal is titled Developing Measurement Tools and Activities with Elementary School Teachers, a design-based research project to support data science practices with environmental data. And I am standing here in front of the teacher education department's laser cutter because I'm proposing that I would like to come to your school and get a machine like this at your school. Why would we get such a machine? So something that I'm pretty passionate about as a former elementary science teacher that worked with pre-K through second graders. One of my main teaching topics was temperature and weather. And I found that my students were not very well prepared to understand longitudinal temperature data. That is, they were able to accomplish the procedure of reading a thermometer, but they didn't really understand what those measurements were. So in order to overcome that obstacle, I created two versions of what I call the early childhood thermometer. It has a color scale, so right now in this room it's 71.5 degrees, and it's going to represent with an approximate bar there. So up to here, that was showing yellow. If it was lower on the scale, it would be blue. If we get all the way to the top, it would be red. So it's a color-coded scale that I borrowed from Everyday Mathematics, a curriculum that we used back in New York. Now, where the laser cutter comes in, this machine right here, this is how I actually produced this thermometer. So it's cut with a laser cutter. It's made out of 1/8" plywood. But this is not the only measurement tool that we can produce. Here's another example. Here's a custom ruler. And I'm going to show what this looks like to cut on the laser cutter in just a little bit. So my hope is that I'm not going to come in and say, well, this is the final version of the early childhood thermometer. Rather, I want to work with teachers to improve on this design and make it so it works best for their students in their school. And this includes not only keeping it as a thermometer, but we can change a few parts inside and turn it into an air quality sensor. So we could measure particulate matter in the air. And this is especially a problem here in Utah, where we are in severe drought conditions, which is resulting in the drying up of the Great Salt Lake. And so we're about to have a lot more particulate matter in the air on a regular basis. So we're going to produce a tool where we can measure how dangerous it is outside. And I want to do this with teachers. So by having a laser cutter at your school, I could run a workshop and the teachers would be trained in using this equipment, and then they would be able to use it on their own as well. But the idea is that I'm not going to ask them to start from scratch. They will be revising on the existing design that we have here. In terms of how many schools I'm going to work with, initially we're going to start with one school in year 1, and then year 2 we'll add a second school. So we'll have 2 sites going, and the idea is that this will be a voluntary opt-in. So if teachers are interested in doing this work together, they would consent to doing so. The hope would be to have at least 5 teachers at each school. Maybe by years 3 and 4, we have up to 10. And then in year 5, we'd want to invite other teachers from other local schools to see how they might be interested in doing this work with us as well, and possibly looking to further funding opportunities to expand the grant so that we could be in more than 2 schools and maybe expand to other districts. So now in the next part of the video, I'm going to show you how the laser cutter works. Right now, won't spend too much time on Adobe Illustrator, but I have a design that includes the drawings, 2-dimensional drawings for this custom ruler, and we'll cut a sheet of these rulers. Okay, in order to print now, or to cut, we're going to execute it as a print from Adobe Illustrator. So we have a computer, And then the two other pieces that we have over here, this is an Epilog mini laser cutter, a 40-watt laser cutter. And then beneath it is the fume extractor, and this unit is very important. This has a series of filters that make the air safe to breathe that's coming out of the laser cutter. So we're not going to smell any smoke coming from here. So first I'm going to turn on the laser cutter. I'm going to turn on the fan as well, the fume extractor. And there is one more device that you'll hear when we're actually cutting, and that's an air pump that's a little out of view. It's underneath the counter here, but I will turn that on in a moment. The last step to actually, 2 steps to getting to cut, we're gonna go to File, Print, and I've already set all of the settings. The laser has different powers and speeds. That's already been established. And I'm just gonna go ahead and hit the print button. The file is now available over on the laser cutter, and the final step I will hit this, what looks like a play button to start that. I'm going to move the camera before I do that so that you can see that process actually happening. And so after about 15 minutes, we have a sheet of cut rulers. Here's one of the finished products. So thank you for considering joining me in this work. See you soon.